Okay, welcome to another term and another physics class. I hope you enjoyed your holidays, and I hope you didn't play all through the holidays. I'm still your physics teacher, Mr. Moses, and we'll be starting this term's work right away. First of all, going through a recap of what we did last term, we went through a few topics such as linear momentum, where we looked at the momentum of bodies in motion. We looked at machines. We talked about the efficiency of machines, where we looked at mechanical advantage and the rest. We also looked at simple harmonic motion, talking about the periodic motion of objects and its characteristics when it is observing simple harmonic motion. And then we looked at equilibrium of force. This term we're going to be starting with matter. Matter, we know, is anything that has space and has size and occupies space, or has weight and occupies space. Matter is made up of molecules which are in constant vibration, and the degree of this vibration is dependent on the temperature of the object. That means that all matter is made up of molecules, and as these molecules exist, they are not standing in one place. Whether it is solid, whether it is gas, or it is liquid, they have different degrees of vibration. For solid, the vibration is not so much. They vibrate about a fixed point that we can almost not sense their vibration in the state of the matter, which is solid. For liquid, the vibration is more than it is in solid. That's why liquid can flow. Solid cannot flow because the vibration is too stiff, too much about a point. But liquid has a wider space of vibration. That's the molecules, just as you can see in the diagram. That's why liquid can flow. And then for gas, the vibration of molecules is so much that when they move, they occupy large distances. That is why if you release gas into a room, it spreads immediately. Hence, matter has to do with molecular vibration at different phases, solid, liquid, and gas. And now we go to heat, which is the first topic of the term. We said it's the average internal energy of a body. It refers to the kinetic energy of the molecules of a body. We understand heat to be a sensation of hotness or coldness, but heat is actually referring to how much vibration the molecules of a body has at a particular time. Okay, it is that amount of vibration that is interpreted by our skin as heat. Okay, when something is hot, it means that the molecules of that thing or that object is undergoing very high vibration. Okay, but when it is cold, it means that the molecules of that object has a reduction in vibration. If it is cold up to 0 point or absolute zero, it means that the molecules of that object are almost not vibrating. So heat has to do with the vibration of the molecules of an object. An increase in heat means that there is an increase in the vibration of the molecules. A decrease in heat means that there is a decrease in the vibration of the molecules. And then we now go to temperature. Temperature is the degree of coldness or hotness of a body. It is a measure of the average kinetic energy of the molecules of the body. That means we said that heat is used to, heat tells us the average kinetic energy of a body. temperature measures that kinetic energy, and when it measures it, it is measured in degrees Celsius, degree Fahrenheit, or Kelvin, which is the absolute temperature scale. Mostly we use Kelvin, but it has 3 scales, which is degree Celsius, degree Fahrenheit, and Kelvin. Now, these are scales that tells us how much vibration the molecules of an object is undergoing. So temperature is simply the measure of how much vibration the molecules of an object is undergoing. Here we have the conversion of different scales. We have the Celsius scale to the Kelvin scale, and hence the formula and the example below. That means for every Celsius scale, to convert to Kelvin scale, you have to add it to 273.15 to get the Kelvin scale. Because in the Kelvin scale, in the Celsius scale, the lowest point is 0 compared to the Kelvin scale of 273, and then the maximum, the upper point is 100 degrees Celsius compared to the Kelvin scale of 373 Kelvin. Now this is the formula to convert from Celsius to Fahrenheit, where C represents the Celsius scale and F represents the Fahrenheit scale. And now we'll go to thermometer. The thermometer is used to measure temperature with the aid of physical properties of different substances known as thermometric substances. We know what the thermometer looks like. We have a picture of it behind the right top here. Now the thermometer, we said temperature measures the average kinetic energy of the molecules of a body. The instrument used to measure it is a thermometer. So when the thermometer reads high, it means the kinetic energy is high. And then we go to the fixed point of the thermometer. We have the upper fixed point and the lower fixed point of the thermometer. The upper fixed point is simply the measurement or the reading on the thermometer when that thermometer is used to measure steam. Yes, when it is used to measure steam. And then the lower fixed point is the reading on the thermometer when it is used to measure melting ice. That means the temperature that it will give you when you measure melting ice is called the lower fixed point of the thermometer. For the Celsius scale, it is 0 degrees Celsius. For the Kelvin scale, it is 273 Kelvin. And then the upper fixed point is used to measure steam. For the Celsius scale, it is 100 degrees Celsius. For the Kelvin scale, it is 373 Kelvin. This is an example of what upper and lower fixed point is. The upper fixed point was used to measure boiling water, where at the point where it is now converted to steam, and the lower fixed point was used to measure melting ice. And then we further go to calculations of upper and lower fixed points, where in this case we are comparing two thermometers. Okay, in this case we are comparing two thermometers. One is of the usual scale of degrees Celsius, which is the one on the right, and then the other one is of an abstract scale. Okay, not all thermometers given to you will be Celsius or Fahrenheit or Kelvin. They might just give you another thermometer that measures in millimeters. Thank you for watching. We'll continue in the next class. I hope you enjoyed the video and understood it. I'll see you in the next class. God bless you.